Hello guys, welcome to the second video of vector analysis. So in this video I'm going to clarify something I said in the last video. So what I mean by A cross B equal to IJK, AI, BJ, EK is that like I missed something over here. So originally there should be IJK3. What I mean by this is that I can choose from 1, 2, 3, and J can choose from like 1, 2, 3, and K also can choose from 1, 2, 3. So the final form of this term is just basically 1, 1, 1 plus 1, 1, 2 plus 1, 1, 3 plus blah 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 blah, and there are 9 terms. 9 terms. And we can see that they're equivalent to each other, but for convenient purposes, we just ignore this. And I think it's called the Einstein convention. Okay, now we're moving on to the second subject, which is to prove this. Y's are equal to each other. This is really difficult to prove, and I did it beforehand, so I'll just show it to you guys. So wait a second. For the first term, we can write it as A cross this and this, which is equal to this. Okay, and moving on, and we can expand out into this form, which is equal to this. And then we move this to that side and get this equation. And from now we can expand out this out. Wait, what the hell? And we can get this. And moving on, we can see this is equal to this. And expand it out, you can write it as IL delta IL times delta GM and times this stuff. And expand it, we can see that this term, which is basically this term times this term, is equal to a lambda or gradient A dot B minus this term over here. So basically, this times this is equal to this. And for this part, we can expand it out and write it as, wait, let me see. What's going on here? Ugh. Oh yeah, never mind. I see. So now we consider this part. First. We expand out the form and we can see that it is equivalent to this. Okay, moving on to the second part. So in this, we just combine the terms first. Okay? Because we need to get these two terms to be like in a form of IJK just here, because so we can write it out like this. So basically this is equal to this, and we can rewrite it as this and expand it, and there should be a minus or plus this stuff, which this part is equal to B cross B cross B cross the curl of A, and plus, and this part is B dot divergent and times A of A. I don't know how to say this. Okay, so basically we have now this term is equal to this term, and we see that A is equal to B is equal to E. So for this case, these two terms are equal to each other, so which is 2 times e and this. And this term is also equal to each other, so move it to that side, which has 2 of e cross and this plus this e dot e. And this part, this one equal minus 2 e this, and divide by 2, then we can get the equation over here. So basically prove this. And for this part, we can see that, okay, wait a second, I need to teach you guys something first. So for e, we can write it out as the first term, which is ei, and the second term, ej, and there's a summation ij, around 1 to 3, and we just ignore this. So when you dot it, so it basically means that I and ei started with I, j, ei, ej, and we dotted with this, so which is equal to I, ei, ej, ej. And notice the order matters. So what I mean is that when you take it like e dot this, it is different from this. So this term is actually equal to ei, ej, ei, j, and dot with j, ej, and this term is out. I'll leave out this to this, okay. And now we're going to take a look at this stuff. So for this, it's just an identity matrix. So when I is equal to j, it is 1, and when it is not equal to each other, it is 0. So basically, if you expand it out, and you will see that I is equal to j, so which resulted in the gradient of 5. Okay, we're done with this video.